that second derivative test that we had from the last video again. So basically it's telling you that f is a twice differentiable function. Selected values of f prime and f double prime are shown in the table below. Which of the following statements are true? Let's evaluate each one of these one by one. So this first one, right? F has neither a relative minimum nor a relative maximum at x equals 1. So here's x equals 1. The derivative is 0. Okay, so having neither would mean that this value right here has to be 0 and not negative, because the second derivative test says if f prime of c equals 0 and f double prime of c is, in this case, let's say less than 0, that means that my function is concave down. That means that if the second derivative is negative, that means my function is concave down at c. So it looks something like the picture that I just drew right here, where this value is c along x, right? So then, and just as the picture illustrates, then f has relative max at x equals c. And if the second derivative were positive, then it would be concave up, and then this would be a relative minimum, and we would switch it around. So this is one case, right? So it's clear that in this case, look, I have it that f prime of 1 is 0, and f double prime of 1 is less than 0. So then therefore, f has a relative max at 1. So this is true. The second one. This first one, that first one is not true. The second one is true, relative maximum. Now let's investigate the last statement. F has a relative maximum at 4. So I have it that f prime of 4 is 0, but f double prime of 4 in this case is greater than 0. It's 1.2. So then therefore, f has a relative minimum at 1. And this one is not true. If 3 said f has a relative minimum at x equals 4, then it would be 2 and 3. But it's only 2 that is correct in this case. And again, you just want to use that second derivative test.